Hello there, I am Untitled. In this video, we will solve one problem in Chapter 7. A 12 kg crate is held at rest initially on a horizontal surface. With the help of a horizontal force of magnitude 88 newtons, the crate is dragged 7 meters along the surface. There is friction between the crate and the surface, which is given via μs as 0.6 and μk as 0.4. Determining first all the forces acting on the crate, calculate the work done by each of these forces. Now we draw the free body diagram for the crate. First, we choose the natural coordinate axis. Then we represent the crate by a big dot. We draw all the forces on the body. The gravitational force due to the gravity of the Earth on the body is m times g, which is a downward force. Secondly, since there is a contact between the crate and the surface, we draw the normal force as follows. Because there is no motion along the y-axis, it has the magnitude of m times g by the Newton's second law. And the external force F is drawn as it is. Finally, since there is a motion to the right, the kinetic frictional force is drawn to the left. As the final step, we draw the acceleration vector to the right, but not on the body, and it is shown by an arrow of different color or different shape. Okay, this is the free body diagram for the crate. The work done for F is calculated by the formula F dot D. Since the angle between F and D is 0, then with the corresponding values, we obtain 616 joules. The work done by the kinetic frictional force is calculated by the formula Fk dot D. The angle between them is 180 degrees. So, since Fk is μk times n, also n is m times g, with the numerical values, we obtain negative 329.28 joules. The work done by the gravitational force is m times g dot d. The angle between the gravitational force and d is 90 degrees, so that we obtain zero work. Similarly, the work done by the normal force is 0, because forces perpendicular to the path do not do work. B. What is the increase in the internal energy of the crate surface system because of friction? We know that the increase in the internal energy is equal to the absolute value of the work done by the frictional force. Therefore, we write delta E thermal equals absolute value of WFK, which is approximately in 3 digits, 329 joules. C. Calculate the change in the kinetic energy of the crate. Here we can use the kinetic energy work theorem, which states that total work equals delta K, where delta K is the change in the kinetic energy of the crate. We know that total work is the sum of the works done by each of these forces. Therefore, with the numerical values, we obtain 286.72 joules, which is approximately 287 joules. So, this is the change in the kinetic energy of the crate. D. Determine the final speed of the crate. Again, by the help of the kinetic energy work theorem, the change in the kinetic energy is found by 1 over 2 times m times v2 squared minus v1 squared, which is equal to total work. Or simply, v2 squared minus v1 squared equals 2 times total work over mass. Then we find an expression for the final speed v2 as square root of 2 times total work over mass plus initial speed squared. With the corresponding numerical values, we determine the final speed of the crate as approximately 6.91 meters per second. Well done, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.